Okay guys, we're continuing on with our write-up for the IA2. Don't forget your draft is due Monday of week 2, so you probably get 2 or 3 lessons in week 1 of term 2 to work on this the remaining parts of your assessment. So if you go to your sites, you're on term 1, obviously go right down the bottom of term 1 as per last term. All the stuff to do with your experiment is here. So I've opened a couple of these already. The important ones are this step-by-step guide, probably useful words, and obviously the number of words per section, and specifically this IA high level one. Don't forget you've got all your original methods there to put in your appendix. You don't need to put them into your experiment proper, just the things that you've changed. Right, so you're up to this section. Obviously you've done rationale, you've done your research question, you've done your risk assessment, you've done your method, your modified method, yep, and the justification of those methods. So in this template, you're up to individual work only now, which you've got to process and present the data appropriately. Now, a lot of you guys didn't have a lot of data, so it's going to be pretty simple to do the tables and graphs. Probably won't be any calculations other than average if you've got a couple of bits of data, so it's not too complex. So what you're trying to do is get a graph, either a line graph or some bar charts if you've only got 2 bits of information to compare to each other. Say for example you did yeast with temperature. If you took it every 5 minutes for 20 minutes, you could have 40 degrees, 30 degrees, etc., and have 4 line graphs. If you didn't do that, so you only measured the outcome, the change, you could just put some bar charts there. Same with if you had balloons, you want to measure the size, you could just put the different sizes at the different temperatures. So it depends on your data. A lot of guys didn't get a lot. So if you didn't get a lot, you just talk about what you've got, but you can also use some secondary data. All right, so you can use some other data, and what you've got to do is have identified or process it properly. So that's averages or percentages, or percentage difference, things like that, and put it into a simple bar chart or something like that. So don't forget there's all the stipulations of how you should write it. So we're going down to right, if you haven't got enough sufficient and relevant raw data, you need to go and find some secondary data. So for this one here, I just typed in data sample, experiment yeast respiration at different temperatures, and I typed in table or graphs, and I went to images, and this appeared, and I just clicked on that link and got some information about a yeast experiment that was done at 10, 20, 30, 40 degrees and how much carbon dioxide they produced. So your data won't be that complex, but if you didn't get complex data, you've only got a little bit, like a couple of measurements, and you need to get some secondary data to back up your statements. Yeah. So do analyze your own data, but then have some other data if you haven't got much data to work with. All right. So you've got some sort of simple table, you've got a simple graph. So what do you need to do? You need to, as I say, get your averages or your percentage differences, and then you've got to identify the relevant trends, patterns, or relationships. Now this is where you want to say, for example, say at 30 degrees there was this amount of carbon dioxide produced, the size of the balloon perhaps, and at 40 degrees there was this amount of carbon dioxide, the size of the balloon. How much greater was at 40 degrees than it was at 30? Some sort of magnitude or measurement. So if you go to what sort of words you need to put in back here on your sites. All right, some good words to use. In this one here, words for scientific writing. Some good words to use would be greater than, more than, slightly greater, increased, things like that. So here we go, more, equal to, less than, dissimilar, different. Yep. So some sort of magnitude of the trend. So this one was greater than that, which means that more carbon dioxide was produced. And if you know how much more, that's even better. More carbon dioxide was produced at 40 degrees than 30 degrees Celsius. There was this much more. Yep. So that's a trends, patterns, and relationships. And you can do that for all your data. Yep. So in this sample one, trends, patterns, and relationships, he interprets each bit of data and analyzes it. So he says, okay, this has got more than that. It's got, this one shows an increased amount of that, etc. And you also need to analyze it to how, what uncertainty you had about your evidence. Right, so if you're confident those averages are correct, then that's fine. If you haven't got enough data to have averages, then you want to mention that in here, the uncertainty, yep, in your data, the results, the actual data, not the experiment, yep, at this stage. And you need to mention what those errors were. There was only 2 bits of data, so you can't get a very good average. If one was wrong, then you're going to have a high error rate. And if you did that, then this is why you use some secondary data. So the average in the secondary data is this. So mine was way off that. So therefore, obviously, I didn't get enough data to be accurate. Yep. So that's identifying the trends, analyzing the limitations of your data itself. And then the next bit is to interpret the evidence to draw conclusions to the research question. Yep. So it's basically one statement, and sometimes they put that conclusion at the end, even though you've got it after this information. So your conclusion might be, based on the evidence that you had, then obviously there is a much greater level of respiration at 40 degrees Celsius with yeast than there is with at 30 degrees Celsius. And this is because the optimal temperature for yeast respiration for enzymes to work properly is 38 degrees, whatever you've researched. Yep. So you match what you know to your data or to your results. And you might want to make a comment about why that's important as well in your conclusion. This is important because we can then know the correct temperature for yeast respiration for producing bread, alcohol, etc., etc. Yep, just one statement. But as long as you've done some sort of conclusion that summarizes your results. So here, basically drawing a conclusion. Yep. In the example one, they put their conclusion after they've analysed each bit of evidence. They put it right at the end, but it's still a conclusion. You could put it straight after you've done your analysis of your data here. Yep. So go and look at that sample one. I mean, it's a completely different topic, but you can see, and the data is a lot more complex. You can see what they do with their interpretation and working out the trends. So the next thing is obviously to then go to your evaluation. So that will be the next video. Thanks, guys.